All right. So this sample exercise is the 10.8 on page 408, calculating the molar mass of a gas. So it got a decent amount of information here. A series of measurements are made to determine the molar mass of an unknown gas. First, a large flask is evacuated and found to weigh 134.56 grams. So we've got the mass. I'm just going to put down some variables here so I kind of keep myself organized. The mass of the flask is 134.567 grams. It is then filled with the gas to a pressure of, so the pressure of the gas, 735 torrs. And the temperature is 31 degrees Celsius, which at 273 gives us 304 Kelvin. Okay. Its mass is now 137.456 grams. Okay, so that's the mass of the flask and the gas together, right? So what do we do to get the mass of the gas? The mass of the gas. Yeah, good. Take that number, so the 137.456, subtract the mass of the flask, 134.567, then we get 2.889, which is the mass of just the gas. 2.889 grams. And we don't know what the gas is yet, so it's just like that. All right. Finally, the flask is filled with water at 31 degrees Celsius. So temperature of the water, 31 degrees Celsius, which equals, we've already done that, same, so 304 K. And it's found to weigh 1,067.9 grams. So we're going to do the same thing with that one. 1,067.9 minus the weight of the flask, 134.567. And we get, the mass of water is 933.3 grams.
Would you do it with a flask of gas in it too, considering you don't want to weigh the gas with it?
What's that?
Considering it's the flask and the water with the gas, wouldn't you subtract the 137?
No, so what we're assuming at that point is that the water displaced the gas. That I see what you're saying, because the way it's worded kind of does make it sound like that. But we're assuming at this point that the water is displacing all of the gas out. So, and then they give us density of water is 0.997 grams per milliliter. Okay. Assume the ideal gas equation applies. Calculate the molar mass of the unknown gas. We want the molar mass of the gas. Equals what? We don't know, in grams per mole. All right, so we've got a lot of variables. This is just, trying to help keep everything straight, and so we know what we have. All right, so if we look at this, we want the molar mass of the gas, correct? So the molar mass of the gas would mean that we would need, so it's dRT over P, right? So this right here is all for the gas. So the reason this one gets a little tricky is, so do you guys remember the what's it called? The solution, like the solution, the Q equals MCAT solution thermochemistry stuff, where We talked about like the solution and the surroundings gaining like what, that kind of thing, and how you had to make it negative because it's like the opposite of it or whatever. You had to watch and make sure, or you'd put all the information in, but it's the information for the solution. So you had to put the negative in to get the reaction, right? So similar here. And when we put in the stuff here, if we want to find the molar mass of the gas, we have to be make sure we're putting in the density of the gas, the temperature for the gas, and the pressure for the gas. Okay? So the reason I bring this up is because, so if we look, we have a temperature for the gas, right? The 304. We have a pressure for the gas. The R is just the constant. We can pick the one we want for that one. So what we need is the density for the gas. We don't have that. We have density of water. So if we think about density, what was our density equation? Well, our density was equal to what? Mass over volume, right? Okay, so that means that for density in here, we can do the mass over the volume of the gas, right? Now let's look, do we have the mass and the volume of the gas? No, we have the mass of the gas, we don't have the volume. So we need the volume of the gas, and here's where the water stuff comes in. Okay, so we know that density, so we've got the density of the water equals the mass of the water over the volume of the water, right? Okay, so if you think about what happened, it had the gas in the flask, right? So that means the gas is going to expand to fill the container. If we're assuming that the flask was completely filled with water. So if we can figure out the volume of the water, that's going to be the same as the volume of the gas. Everybody okay with that idea? Because the water filled the container, and we know that whenever you put a gas in a container, it expands to fill the container, right? So we've got density of water, 0.997 grams per milliliter. And we got a mass of no, wait, that's the gas. Where's the water mass? Here, 933.3 grams. We're looking for the volume, right? So we basically take the 933 divided by the 0.997, and we get the volume of the water to be 936 milliliters, which means the volume of the gas, 936 milliliters. Oops, sorry. There we go. So far, so good. Questions? Okay, now let's look at I'm just going to kind of asterisk over here the stuff that we need for the gas. So we need the mass of the gas, which we have right here, right? We need the volume of the gas, which we have down here. We need an R factor, which we can add in a second. That's the constant. Temperature of the gas, which is right here. Pressure of the gas, right there. All right, so we've got all the parts. Now we need to decide what R factor to use. So again, this is going to be based on the labels. So if you look, we've got torrs, kelvins, gram, and milliliters. So torrs, kelvin, this is liters though, right? So what you want to do is probably the easiest way. You could convert the R factor, but that's kind of a pain. I would just change the gas from milliliters to liters. You move the decimal 3 to the left, 0.936 liters. Now, if we go up here and we plug everything in, Okay. Mass of the gas, 2.889 grams over the volume, 0.936 liters, times our R. We're going to use the R, the torr one, this one. So 62.36. That one is liters, torrs, over moles K. Our temp, 304 K. All over 735 torrs is our pressure. Everybody okay with where we got the numbers from and why we're putting the stuff where we are? Now this is a math problem. You divide this divided by that, times that, then divided by that, and we end up with a molar mass of 79.6. And the label we're left with, if we look at the stuff that cancels, liters cancels, torrs cancel, K's cancel, we're left with grams over moles, which is our molar mass label. So it worked out perfectly. There we go.